So I wanted to take a little time to look at some trig inverse thing when it's a composite function. So really, let's just start here. So sine inverse of square root of 3 over 2. So really what that's saying is when, what angle is the sine value of square root of 3 over 2? So I think about that and I'm like, okay, here, well, sine, that's my x value, so that's the high ones. Okay, so here's that's when my sine is square root 3 over 2, right? Those are my pi over 3s. Okay, so positive, that's here and here. Okay, so I'm going to go with those two. And also, there are going to be some domain restrictions. So back on a different video, I showed you kind of, so here's sine and here's sine inverse. And so the places that we use sine inverse is just quadrants 1 and 2, because that's what's happening in the sine graph. It looks kind of like here. And so that's pi over 2. This is, hold on, we got to move that down. Let's move this down to there, right? Okay, so this is negative pi over 2 to pi over 2. So negative pi over 2 to pi over 2. That's where we can inverse our graph. Okay, that said, so that's just like, so that's here to here. So we're going to label this negative pi over 2 as positive pi over 2. So the context is that we're going to use those numbers. So this is positive pi over 3 up here. This is negative pi over 3 down here because of the context, what I'm calling it, just at this point in time, how I'm using the unit circle. Now, sometimes the context will be 0 to 2 pi. Then the answer would, for this question, would have been pi over 3 and 2 pi over 3. But contextually right now, we're just looking in quadrants 1 and 4. Okay, so where is the sine negative 1/2? Well, that would be this. That would be at a pi over 6. And in this context, that's going to be negative pi over 6 because it's going down. Sine of 5. Well, think about the graph. That the highest the sine can get is, I'm like, you can't see that. If you could see my whole body, I had it way up high. So the highest it can get is 1. So that's undefined. Can't do that. Okay, now this one, it's a composite. Now technically, sine inverse and sine undo each other. Okay, and at the same time, we have to think about, yes, they undo each other, but we have to work within the constraints we're given, which at this point in time is negative pi over 2 to positive pi over 2, and 5 pi over 6 doesn't fit within those constraints. Okay, so I'm just going to kind of draw it out. I'm going to figure out what is the sine at 5 pi over 6. Well, that's over here. 5 pi over 6, or is it over here? I don't know. Like, you're backwards. Okay, so 5 pi over 6 for me is right here. So 5 pi over 6. The sine of that is positive 1/2 because it's above 0, right? So that's like right here. So it's 1/2. Then I'm asking, okay, where is the sine inverse? Where, like, what angle is the sine equal to 1/2? Well, this one is out of my range, so I've got to say what gives me that inside? Positive pi over 6. So even though, yes, these technically undo each other, then I have to bring it within the correct domain. Okay, this one right here. So sine and sine inverse, they undo each other, but I have to make sure, is this in the right place? Well, the inverses have to be between -1 and 1. How come? Because what I do is on the inverse, I take, so like the domain of the original is negative pi over 2 to positive pi over 2, and the range is -1 to 1. Well, the inverse, I swap those. So now my domain is -1 to 1. And my range is negative pi over 2 to positive pi over 2. Okay, so I look at this. Does this fit within there? It does, so I don't have to like swap it over to the other side. So my answer is just 0.85. Okay, let's, I'm going to do just a totally random one with this sign, but I'm going to make it look weird. I'm going to say sine Inverse of sine 5 pi over 9. And you're like, over 9? We've never done over 9. Yeah, that's totally fine. Okay, so here we go. I have to figure out, where does 5 pi over 9 live? Well, this is a whole pi, which would be 9 pi over 9. This is 0. Okay, what's halfway? Is 5 pi over 9 more than halfway? It is, because half of 9 would be like 4.5. Now, that's wonky. You wouldn't actually write it like that, but I'm just trying to get a reference point. So 5 pi over 9 is right here. Well, you know that the sine has to live over here because that's just my constraints. So then I have to figure out, how do I swap this one over into the right side and get the same sign? Well, that would be like right here. Yes? And I'm going to tell you it would be right there at 4 pi over 9. Because my reference angle, 5 pi over 9, my reference angle is 4 pi over 9. So I just swap it over there, same. So what is the angle that gives me that? 4 pi over 9. So these technically undo each other, but it was in the wrong place, so I have to flip it into the right quadrant. There you go. I'm going to come back and do some with tangents, because the tangent, like where it is, if you have to swap it, is interesting.